So cool. Okay, the number system. So we just classified two types of numbers, right? We classified things as rational or irrational, which is awesome. There's actually a whole bunch of different types of classifications for numbers. Okay, so I kind of tell it like as a story through time because that's how it actually happened. So way back when, way back when they first started talking about numbers, they talked about counting numbers, right? So things like 1, 2, 3, 4, like the basic numbers, what you would teach a little kid, really. And they thought those were the only numbers that existed. Like they didn't think there was anything else. Just these numbers, 1, 2, 3, 4, 5. I think I could count on my fingers, toes, or with apples or stones or whatever the heck they were doing back then. They called those the natural numbers because that's the first set they ever came up with. Okay? They represent natural numbers with the letter N. So if you look, they've put it right here for you. Whoa. Natural numbers with the letter N. Okay? Natural N. It's only counting numbers, starting with 1. Then, and it took a long time, they believed in that for a very long time, that those were the only numbers that existed until somebody was like, how do you represent nothing? Right? What if I have no of something? And then they came up with the number 0. And they're like, well, that zero's got to exist. And if you ever talk to a little kid, they can usually count, but they can't count 0. Right? Because they can't comprehend like 0 things. It's kind of funny. And then you try to teach them and they're like, I don't know what 0 is, and they can't do it. So it's kind of like a little child learning numbers too, is how history started a long time ago. Once they learned the number 0, they're like, okay, but 0 is not a natural number, right? Because it wasn't there when we initially thought of these things. So they had to create a whole new group of numbers just to include the number 0. They called that the whole number system. Whole number system is represented with a W. So when we talk about the W number system, it's all the counting numbers, 1, 2, 3, 4, 5, because those things existed. Now it includes 0. Okay, so it's all those numbers plus the number 0. It's the only thing that's different between these two, which is kind of crazy. As time went on, and that went for a long time again, they kind of discovered that there was a whole other set of numbers that they'd ignored, and it was negative numbers. Right? It was going backwards. Right? Because they started counting backwards. They go 3, 2, 1, 0, and then they're like, well, you have to be able to keep going. Right? So they created negative numbers. -1, -2, -3, -4. And again, they said, well, if we have negative numbers, those aren't a part of our natural numbers, right? Because they weren't there when we first thought of this. They don't count as whole numbers because they're not quite whole numbers. They're something else. So they created a new term called integers. Integers are all my counting numbers. 1, 2, 3, 4, 5. It includes 0, and it includes negative whole numbers. Okay, so you'll look, integers is an I, and it includes all my natural numbers. It includes my whole number, but now it has all these included as well, all my negative numbers. That's a big set of numbers, right? Awesome. The last thing they came up with, it took them a long time again, was in-between numbers. Right? So you have like all these numbers, you have 1, 2, 3. Like, well, what happened? Like, what's in between 1 and 2? And that's how they came up with decimals. And then they realized there was 2 types of decimals, right? There was rational decimals and there was irrational decimals, which is what we just learned about. So a rational decimal is something that terminates. 2.5. Beautiful. It stopped. Another rational number is a number that goes forever, right? 1.333333333. Right? They deemed those to be rational because they could represent them as fractions. Irrational numbers were numbers that went forever, that never repeated in any way.
Excuse this interruption.
So when they broke it into rational and irrational, they then had to also sort all of these things. All these numbers are terminating decimals. They all are. They're all 0.0. We just don't write 0.0. These all still count as rational numbers. Unfortunately, rational numbers aren't represented with an R. That'd be really nice and easy. They're represented with a Q. All right, so when we say rational numbers, we use the letter Q. Irrational numbers are represented with a Q with a line over it, like this. Rational numbers include everything we've talked about up here, naturals, wholes, integers, plus any decimals that terminate or repeat forever. Irrational numbers are like their own separate thing. Irrational numbers go forever, never repeat. Awesome. The reason they didn't use the letter R for rational is because they had created a set called the real number system. These are all numbers that actually exist. So they call them the real number system. That's why real is R. So when you see R, that means real, not rational. These are all real numbers. Okay? You'll never deal with a non-real number. A non-real number is called an imaginary number. Like that's actually a thing, imaginary numbers. You won't learn about that until your second or third year of calculus in university, if you ever go that far with math. And I hope you never have to learn about it because it's just confusing and it makes no sense. Awesome. We're going to represent this whole number system in a nice little chart. This guy right here. Okay. We're going to call this like the number system. We start from the inside of the number system. And we're going to build our way out. So we have this little bubble right here. This is the smallest group of numbers that we have. The smallest group of numbers we have would be the natural numbers. Because these are counting numbers, right? Like 1, 2, 3, right? And so on and so forth. The next biggest bubble. So if I expanded this bubble, would include all the natural numbers, right? Because it's inside the next bubble. But it would also include the number 0. And those are our whole numbers. You'll notice the natural numbers, all natural numbers are whole numbers. That's why it's inside the bubble. Awesome. The next biggest bubble we get would then have, I want blue. You'll notice that all the natural numbers and all the whole numbers are inside this big blue circle. Now we also have to include negative numbers because this is the integers bubble. So it would be like -3, -2, -1, and so on and so forth, right? I can't do dots with this, it just connects the lines. So the integers is all your naturals, all your wholes, and all your negatives. The next biggest bubble isn't a bubble, it's a square. We'll do purple. We have this square right here. That big purple square represents all of our rational numbers. We represent rational with a Q. You'll notice that all the bubbles were inside rational numbers. So like the number 1, it's a rational number. It just also happens to be a natural and a whole and an integer. Rational numbers, again, you could write the definition for yourself if you wanted, but they're numbers that terminate, repeat forever, or could be written as a fraction. And that might be the best way to know it. Fractions are rational. You'll notice this little sliver on the sides. And that little sliver on the side right here does not have any of the other things inside of it. That's because these are like their own thing. These are your irrational numbers. These are numbers that go forever and never repeat. And none of these are a part of that little sliver on the side. That's why it gets its own little side portion. The entire system is called the real number system. You will have to be able to classify numbers. Right? So if I give you a number, I'm like 3.5. I'm going to ask you, which groups does that belong to? And 3.5 is not a natural, it's not a whole, it's not an integer, but it is in the Q. So you'd say it's a rational. I could give you another number. I could be like, what's the number 2? And you say, well, the number 2, it's a natural. It's also a whole. It's also an integer. It's also a rational. And it's also real, right? So the number 2 actually belongs to a whole bunch of systems. We'll work on that throughout the year because we'll always be classifying things. We'll say like this is part of that group of numbers. So it is kind of important that you understand the letters, the notation, N, W, I, Q, and Q with a line over it. Also R for real. And what belongs to each group. The next little part is on estimating, right, square roots and stuff like that. We're not going to do that. We're going to start square roots on Monday. Okay. If you want, we'll do these ones right here. So we're going to look at the number 9. For each, we're going to write the set for each of them. So the number 9. The number 9, start from the inside out, is a natural. Right? It's a counting number. I could do it on my fingers. If it's a natural number, it's also a whole number. So it's also in the group W. If it's a whole number, it's also an integer. So it's in the group I. If it's an integer, it's also in group Q, because it means it's rational. If it's a rational, it's also in the group R, for real numbers. So when I talk about the number 9, it belongs to 5 different groups: natural, whole, integer, rational, and real. The number 11 over 7. The best thing to do, in my opinion, is to change it into a decimal. So when you go 11 divided by 7, you get a decimal. What is that decimal by?
1.571428.
Oh gosh, that one again. Right? And it keeps going. It does repeat though, right? It's like 5714. What is it? 571428, then 571428. Like it will repeat itself. Okay. Change it into a decimal. Now we can classify it. Is that a natural number? Can you count it on your fingers? Definitely not. Is it a whole number, meaning you can count on your fingers, or it's 0? Definitely not. Is it a integer? So you can count it on your fingers, or go backwards and count it on your fingers, like -1, -2, -3. As soon as you see a decimal, you can automatically eliminate all of the first 3, because all of those aren't decimals. Now you got to decide rational or irrational. If you look at your calculator, it does repeat, right? It goes 5, 7, whatever it was, something 1, 4. Also, it started as a fraction. Anything that can be written as a fraction is automatically rational. Right? So you can almost use that quick trick to be like, no, it's rational. If it's rational, it's also real. And real is like an R with like a second line down the left-hand side of it. That's why you always see me kind of put that second line on it. Awesome. If we look at number 3, we have the square root of 5. When we put the square root of 5 in our calculator, we get 2.236067977499979. Right? That's a decimal for sure. So it's not natural, it's not whole, and it's not an integer. Because it has a decimal value. Now you've got to decide, is that rational or irrational? It goes forever, so it never doesn't terminate, and it doesn't repeat. Non-terminating, non-repeating means this thing is irrational. So a Q with a line over it, and it's real. Everything in this class will be real, so just keep always adding R onto every number. An example of a non-real number would be if you did the square root of -2, and your calculator would just say error, because it's like, that's not real. If you have a newer calculator, it even says non-real number on it. It's like, oh, you don't want to deal with that. Last one, -7. Start from the inside out. So a real, or you start from the inside. A natural number is a counting number, right? 1, 2, 3, 4, 5, 6, 7. That's not a counting number. Can't count on my fingers. It's not a whole number because it doesn't include the number 0. But it is an integer because I can count it on my fingers but backwards, right? So this thing is an integer. Integers are rational. Rationals are real. That thing belongs to all 3 sets. Awesome. Tonight, try to practice